The use case that we looked at here was essentially this use case where we said we'll have multiple GraphQL services. The nice thing is that these can be any GraphQL services. So these can be handwritten GraphQL services. These can be GitHub or Shopify or whatever, like external GraphQL services. There's no upstream modification that's required. Those are just vanilla GraphQL spec services. The metadata at Hasura is kind of what contains all of the information about what those relationships are. So let's say you've built an existing GraphQL API that clients are using, that applications are using. And now what you want to do is you want to add certain advanced capabilities to your GraphQL API that are very tedious to add, or that are hard to add, right? For example, you want to add subscriptions or streaming, right? And you don't want to build that in a GraphQL service, right? Or you want a flexible API for the read side of your GraphQL API where you want pagination, and you want filtering, and you want sorting, and you want aggregations, right? So you want those capabilities, but you don't want to build that in your GraphQL API. And in those kinds of use cases, this model that Hasura has of being able to do GraphQL to database joins, not GraphQL to GraphQL joins, but GraphQL to database joins, also becomes really useful. So now the third piece is adding custom resolvers to the GraphQL, to your existing Hasura GraphQL API. It's essentially the same thing that we looked at before, but this is more for existing Hasura users who are using remote schemas today, who are using databases today, who want to start kind of setting up relationships between their database and with their custom resolvers as well.
Hi, everyone. Thank you for joining us today for our deep dive into data federation with GraphQL Joins. My name is Star, and I'll be your moderator. Today, we're excited to have Taimei, co-founder and CEO of Hasura, join us for the session. So without any further ado, I'm going to hand it over to Taimei.
Hey, everybody. Cool. Excited that you could join us today. What I'll be doing is just kind of doing a super quick overview of GraphQL Joins, which is a recent capability that we announced that kind of furthers the data federation capabilities that we're building on at Hasura. All right, you should be able to see my slides as well. Cool. So I'm going to take you over just kind of a quick intro to how Hasura works, and then we're going to dive straight into GraphQL Joins. So at a very high level, this is kind of the problem that we're seeking to solve, right? That red box is where Hasura sits. When you have applications on the edge, whether they're serverless functions or apps, whether web or mobile, or even third-party developers who want to kind of access data over an API, building that piece out that can connect to one or more systems becomes tedious. There's a fair bit of tedious work there, and there's some domain-specific work there, right? And if we kind of just unpack that layer, and again, for those of you familiar with Hasura, you'll see kind of this in the API that Hasura creates. It's largely a problem around three areas, right? The first is that you want a native JSON API and an HTTP API. The second, because that's kind of what modern systems on the right are consuming. The second piece is that you want to make sure that there is a layer of authorization, because that's the reason why these edge apps, the big reason behind why these applications and services on the edge are not directly accessing those data systems directly, right? There's a security context that's very different for systems that sit here, and a security context that's very different for systems that sit here, right? You can't have a mobile app that can directly query an account in a database, right? There has to be a security layer that gives them the right entitlement. So that kind of becomes a domain-specific problem to solve this layer. And the third, of course, is performance, concurrency, caching, and stuff like that, which ensures that you have an API layer that can kind of scale with the kind of workload, both in terms of workload, but also the types of usage, right? This is very HTTP stateless connections, whereas these are typically slightly more stateful connections that you have to connect with. So those are kind of the problems that Hasura solves, and that kind of also guides our roadmap, right? We're making like continuous progress towards solving more and more problems that can automate this layer as much as possible. So for those of you familiar with Hasura, you'd see that Hasura already supports connecting to a set of databases. So we have Postgres, we have SQL Server, and BigQuery that we added recently. And those are the databases that we support. We recently added the capability. We've been working on it for a while. We demoed that last year, but we added the capability to do database to database joins. So when you add Hasura and you point Hasura to a database, you're going to be able to take models, either tables or views or procedures or functions, right? And you're going to be able to create relationships between them within the same database. But you can also create relationships on models across databases, right? So that means that if you need to have separate databases for, say, compliance reasons, or because the workload is different, right? You have an HA Postgres connected to like a single instance Postgres that has a small amount of data. Those kinds of use cases become possible, right? And so those are, database to database joins. So that's kind of one element of being able to unify data across two databases. Hasura also supports remote schemas. And so remote schemas are remote GraphQL services. So you can connect to remote GraphQL services and use Hasura mode as a GraphQL gateway that is bringing that remote schema in. The feature that we're talking about today, GraphQL Joins, is an enhancement specifically for remote schemas, right? And we'll get into that in a bit. The third type of source that Hasura also supports are REST APIs, that we call actions. And we recently added that capability for transforming those REST APIs into GraphQL contracts. So you can add a transformation layer that specifies a GraphQL contract for a REST API, right? So those are the kind of sources that Hasura supports. And over time, we're adding more and more capability for being able to join across these heterogeneous systems, right? So today we do database to database joins. We're announcing GraphQL to GraphQL joins, GraphQL to database joins. And next up for us will be action to action joins, so that you can join across two REST APIs as well, right? So that's kind of where Hasura sits in the stack. For those of you who are not particularly familiar with Hasura, that's kind of where Hasura sits. Now, this is kind of an internal representation, or this is kind of a representation of how Hasura works or solves that problem internally, right? Hasura has a metadata engine, right? So there's every time you're using the Hasura UI, what you're essentially doing is manipulating Hasura's metadata, right? And Hasura's metadata is kind of like its source code, right? Just like how if you were building your own GraphQL server, you would write source code to build your own GraphQL server. With Hasura's metadata, what you're doing is you're writing Hasura metadata that, creating Hasura metadata that Hasura as an engine uses as a quote unquote source code or configuration to create the GraphQL API, right? So whether you use the UI, whether you're writing raw JSON, whether you're using API calls to manipulate that metadata, it doesn't matter. Essentially, that metadata is kind of the source of truth for Hasura. So in that metadata, when we kind of look at different types of service, different types of sources, the first part of that metadata is, you would have noticed that there's a tracking table, right? Or add remote schema, or add action, or add a transformer for an action, right? All of those kinds of things are at this mapping layer where you're trying to map resources that you have into things that you want on the GraphQL API, right? The second step of the metadata is to add authorization rules to those models that you have, right? And the close third step, and often there's a little bit of a loop between the second step and third step in the way that you iterate on it, is to now create relationships across those models, right? Once Hasura has these three pieces of metadata, Hasura generates a GraphQL API that can do all the GraphQL things and all the API things that you would want when you would want a flexible API, right? So you can do querying, pagination, filtering, sorting, aggregations, especially on data sources directly, right? Cross-domain joins across GraphQL and databases, which we're talking about today, GraphQL, which we're talking about today, support for streaming in real time, which again, Hasura does with databases really well. Of course, upstream GraphQL services and REST services don't themselves support streaming in real time very well, although we've had a lot of requests for supporting remote schemas and GraphQL subscriptions on remote schemas. That's still something that we're working through. Because the handoff can get a little bit complicated. So there are different patterns and ways of achieving that. But when you think about those GraphQL capabilities, Hasura is trying to automate those GraphQL capabilities on these sources, right? So that you're not worried about the kind of creating, operationalizing, maintaining, and taking that GraphQL API to production. We want Hasura to kind of be able to take care of that for you while you only work at the metadata layer. So that's kind of where Hasura sits in the stack and how Hasura works at a conceptual level. We'll dive a little bit deeper into GraphQL joins now. Okay, cool. Let me just check on. It seems that my camera might not be working, but I think everything's checking out on my end. It's okay. My face is not super important. As long as you can hear me and see my slides, it's fine. All right, so let's take a look at GraphQL joins. So I'm going to just play a super quick video that's a recorded demo by Jesse. And I just kind of, and we'll take a quick look at that and we'll pause for questions and then we'll dive a little bit deeper into use cases just after that. So let me just bring that up.
Hi, and today we're going to have a look at the new remote to remote source joins inside of Hasura. We'll notice that we have an empty schema to begin with, and we'll start by adding our first remote source that is a locally hosted store model that includes items, orders, and things of that type. Next, we'll add our warehousing or fulfillment API that includes things like fulfillment of those orders. Now we will define a relationship between these two services so that we can actually store the order information on the fulfillment itself. This reduces the amount of round trips and plumbing that we have to take care of within our applications. We'll define the input arguments here as the order ID from the order field. And just like that, we have orders on our fulfillment type. Let's run that query. Now we'll have a look at applying permissions to this model. Here we've added a bearer token that has 0 permissions for this remote API. Let's add those now for the role clerk, which is identified inside of our JWT. We'll extend those permissions to the store model as well. Now we can see that our clerk role has access to our entire remote schema. Let's remove one of the columns and we'll hide the quantity from the clerk's view. Here we can see that we've added that granular permission to a remote join from one service to another service, all without modifying the baseline schemas. That's the power of Hasura.
So just to kind of walk you over that demo, and I'll show you what the live example of this looks like. The idea is that you have 2 GraphQL services that have 2 different models. And what you're able to do is you're able to kind of take a scalar field, and in this case from kind of a store or order model, right? And connect that to the item and the item information that might exist in another GraphQL source, right? And the wiring that Hasura is doing is pretty straightforward conceptually, right? It's essentially saying that if we're able to take the value of a particular scalar field and we can use that as an argument, right, for another resolver, then what we're able to do is kind of conceptually see that it's kind of joining across these 2 types, right? So it's the value from a scalar value from one particular result that is being plumbed into an argument for another resolver, right? That's conceptually just it. And that's kind of how Hasura is able to kind of do these joins. So that's how Hasura is kind of bringing together these 2 types. And Hasura can do this within the same GraphQL API. You can do it across GraphQL APIs as well, right? So even within the GraphQL API, if you notice that you have resolvers or that are returning types and you want to kind of connect them, then Hasura can also help you plumb within the same GraphQL API as well, right? So that's kind of a quick look at how that works. And I'll go into some use cases and kind of how it also works on the GraphQL plus database side of things and what those use cases look like. All right, so the use case that we looked at here was essentially this use case where we said we'll have multiple GraphQL services. The nice thing is that these can be any GraphQL services. So these can be handwritten GraphQL services. These can be GitHub or Shopify or whatever, like external GraphQL services. There's no upstream modification that's required. Those are just vanilla GraphQL spec services. The metadata at Hasura is kind of what contains all of the information about what those relationships are. And like Jesse showed us in the demo, what those permissions are that tell us what fields and what attributes are visible for what scope, right? So Jesse, for example, created clerk scope, and the clerk scope said that the quantity is not kind of accessible. And that's kind of what allowed us to hide that quantity field from the clerk scope in the GraphQL API, right? And so that didn't even show up in the GraphQL schema that was made available to for the clerk scope. So when kind of Hasura is doing this, and we're using Hasura here in this case as a GraphQL gateway, right? It's slightly different from using Hasura as a GraphQL backend for a particular piece of for a particular application where you're connecting that to domain data directly, right? So slightly different architectural pattern of using Hasura where you're using Hasura as that GraphQL gateway. The kind of apart from the security side of things, being able to join across systems to prevent N+1 things, Hasura also provides controls there to namespace it or to prefix and suffix things so that you can avoid type conflicts. And if there are type conflicts, you'll see metadata inconsistencies, and Hasura will warn you that this metadata is inconsistent so that you can go kind of fix it. Now, all of that happens at this layer without you having to talk to the authors of people who are maintaining these different GraphQL services, right? This model has some interesting trade-offs, right? One is the kind of the pro here in the way that you think about deployment is that there is no burden on the authors and the maintainers of these upstream GraphQL services, right? All of the work is kind of taken care of by the Hasura administrator at this layer, right? This also has kind of an impact on the way that you think about, for example, CI/CD, right? So when you're thinking about the evolution of that schema, the way that you would want to integrate, there's a whole bunch of tools in the GraphQL community that will help you check as your schema is put together, whether that's a valid schema or not, and things like that, right? So as you kind of, for example, update these upstream GraphQL services on the Hasura side, you want to keep that metadata updated, right? And that might be as simple as asking Hasura to reload its metadata, or it might actually require you to add annotations to Hasura's metadata so that you can see joins across these different services. And as you set up those metadata snippets to say, let's join across these two services, Hasura creates the GraphQL schema. And then when you look at the GraphQL schema, you can see if that's going to work for you or not, if that's a breaking change or not, and stuff like that as a part of your rollout process, right? But that is happening by people collaborating on, say, a GitHub repository or on the metadata of this piece, right? So the shared artifact, because you're fundamentally bringing multiple services together, the shared artifact is going to be the Hasura metadata. That's kind of the collaboration point between these different, for the administrator or between the authors of these different GraphQL services to bring that entire system together, right? In addition to kind of providing that security layer and the joins ability and the way that kind of metadata evolves, Hasura also offers GraphQL caching, and this is at multiple levels. So there's the kind of data loader memoized style caching, and the way Hasura kind of traverses the tree and decides how to make the fewest number of requests possible, not fetching repeated data or redundant data from upstream services within the lifespan of the same request. There's kind of that in request caching or memoization, or you can call it data loader, that Hasura takes care of. But there's also, for example, on Hasura Cloud, there is Hasura also has supports for caching, and so that also now extends to the GraphQL kind of the unified GraphQL API that Hasura is exposing. So you're getting that ability as well. The third, which is something very interesting that we've seen across with our enterprise customers and users over the last few months, since we launched this feature, is restified endpoints. So, and a common situation that happens is that it's not a binary journey to move to GraphQL, or even have GraphQL, right? Because when you expose a GraphQL API, you still might have clients that prefer REST APIs for one reason or the other, right? Two common reasons that we see people wanting to have a REST API on top of whatever it is, right? Whether it's GraphQL or not, is one, that they have legacy clients, right? So they don't want to use GraphQL, they can't use GraphQL, it's painful. It's technically not, right? Because a GraphQL request is very similar to a REST request over HTTP. But depending on who the client is, who the customer is, you might not be able to ask them to use GraphQL on day one, right? So they might prefer REST endpoints. The second common use case is that often when you're exposing these APIs over something like a CDN or a proxy, and you're internally running Hasura, you might need to convert those into GET endpoints, right? So that clients can kind of use those GET endpoints, and the upstream server should worry about it, but the downstream kind of the caching layers or the CDN layers, they might only support GET requests, right? Especially for caching, and that becomes very valuable, because when you're able to create a GET endpoint out of a GraphQL query, that becomes very useful, because you can have a named query, right? Like we looked at the example of orders and fulfillments. You can create a GET endpoint there called /orders, right? With a parameter that takes in an order ID, say, that returns the exact GraphQL result that you would want it to, but it's essentially templated to that GET endpoint, and that has value for these kinds of use cases where you're thinking about either legacy clients or you need get endpoints for supporting some other infrastructure that you have. And of course, now because this is REST, your additional kind of monitoring, tooling, etc., will also just continue working in the same way. So that's kind of one use case here, or one way of thinking about Hasura in the GraphQL kind of gateway mode, and the value that Hasura is adding at that GraphQL gateway layer, right? Moving on to just take some quick questions here. For on-prem deployments, is the Hasura caching layer configurable and scalable? That's a good question. Krishna Kumar had a question on for when you self-host Hasura, does Hasura have a caching layer that can be externalized? Yes. We currently support it on the enterprise version of Hasura. We are working on kind of making that a little more accessible. So over the coming year, you'll have an easier way of kind of just accessing that. But today, if you have like this urgent need to try out that caching piece, please feel free to reach out to us, and someone from our solutions team will help you quickly set that up with your existing Hasura setup so that you can try the caching piece out. But making this a little more accessible so that everybody can kind of start using it along with Docker wherever they're running Docker. Today is a little more complicated to set that up. But even in the way that it works today, and the way that it will continue to work, you can always create an externalized cache layer. So you can hand it off to AWS Elasticache, you can hand it off to your own Redis, that Hasura will use as a kind of centralized cache layer. So that should work. All right, let me just quickly. Cool. All right. Moving to the next example. So this is another example that we've been working on with a few users. And this is a case where you have an existing GraphQL API and you want to enhance your existing GraphQL API. So let's say you've built an existing GraphQL API that clients are using, that applications are using. And now what you want to do is you want to add certain advanced capabilities to your GraphQL API that are very tedious to add or that are hard to add, right? For example, you want to add subscriptions or streaming, right? And you don't want to build that in a GraphQL service, right? Or you want a flexible API for the read side of your GraphQL API where you want pagination and you want filtering and you want sorting and you want aggregations, right? So you want those capabilities, but you don't want to build that in your GraphQL API. And in those kinds of use cases, this model that Hasura has of being able to do GraphQL to database joins, not GraphQL to GraphQL joins, but GraphQL to database joins, also becomes really useful. So let's take a quick look at what that looks like. So let me just, there we go. So yeah, here's a project that I have set up. It's the same order of the fulfillment example that we looked at. So we have fulfillment and store here. This returns, if you look at kind of the traditional order item here, you'll see that orders are returning an item ID, right? Now, let's say that, and they're returning an item that has, you know, name and price, etc. Right? Now, awesome. So now what I want to do is when I'm looking at this kind of setup here, right? What I want to do is I want to be able to connect that to an item model that I have in my database, right? And this has items here, right? And I want to, what I don't want to do is I don't want to create a GraphQL API for this extra information here to handle reads on this side, right? I want Hasura to take care of that because Hasura is going to give me a good read API. It's going to be performant. It's going to be secure. And I'm going to get bells and whistles around it, right? So I want to use this part in addition to the existing GraphQL API that I have. So what you can do is you can essentially set up relationships from your GraphQL API to this data model, right? So just taking a look at what that might look like, it's kind of what this looks like. You can select a type here and you can say to a particular item, I can connect that to a remote database here. So let's say, let's call it info, and I can go in here and choose a particular item. I can choose the database that I want, right? And then I'll map a particular field. I'll map ID to ID in my database model, right? So this is the source field. This is the scalar field that's going to contain the value, and I'm mapping that to the column value in a data model, right? And I can go ahead and create that relationship. And as soon as I do that, I'll get an item info here that I can start to kind of query, and I can get brand details information from that system, right? Let me fetch it with all orders instead so that we can just see what that looks like. Cool. So, oh, my bad. That's it. I'll set that. I'll create that relationship. So there you go. So, so when you take a look at, when you see what this kind of looks like, you'll see that this information now is kind of coming in from the data model instead, right? And in addition, of course, I get the usual API that I would with Hasura, where I have the item info. I can fetch that as I need to. I can aggregate across that the way I need to. And so those capabilities are kind of built in. And I don't need to worry about that, but I can also cross-reference that with my existing GraphQL API. So the way that you would want to kind of use both together, especially if you're thinking about augmenting your existing GraphQL API or moving some of the read workloads from your existing GraphQL API to Hasura, that process also starts becoming possible with this GraphQL to kind of database capability on the Hasura side. All right, the next piece is a similar variation of that architecture, right? Where what I can do is, yeah. So, and especially for things like subscriptions streaming, this works really well. One way that we've seen people kind of use subscriptions with Hasura is that they'll have a subscription model in Hasura that they'll read from, and their existing API or their existing system will basically write events, write updates into the data model, and then Hasura will just have a subscription over that model so that you can expose that to the application. So that also becomes a nice way to use Hasura there. Now, the third piece is adding custom resolvers to the GraphQL, to your existing Hasura GraphQL API. It's essentially the same thing that we looked at before, but this is more for existing Hasura users who are using remote schemas today, who are using databases today, who want to start kind of setting up relationships between their database and with their custom resolvers as well, right? And so what you would notice today is you're able to kind of do joins between databases and GraphQL services in both directions, right? So let's just take a look at one direction here, which is that, let's take a look at one direction here. So you can create a relationship from your data model to a remote schema, right? So that means that you want to add a field to your data model, right? That is not available in your database, but that's coming from a remote schema. That's coming from your GraphQL service, right? Maybe there's extra information here that's associated with this that's coming from an externalized GraphQL service. So you can create a relationship from the data model to a remote schema. So I can say, what extra info or extras, brand, whatever it is. And then I can connect that to a remote schema, right? Which is kind of just the other direction, right? And then pass that in as an argument, right? So I can say whatever, connect the brand ID that I have and say, hey, this value comes from brand ID, right? So I can kind of, that's one setup, that's one direction that you can go in. But then the other direction also becomes possible where your remote schema is returning references, is returning IDs, and you don't have to specify those types again. It can just return an ID, and that ID can cross-reference from the remote schema to the database. That's the example that we looked at previously. So both of these directions, from DB to GraphQL and from GraphQL to DB, are now possible. And that makes it easy, especially if you already are using Hasura and remote schemas and you want to start setting up better relationships between these two systems. So that's that's another kind of variation of this use case, which is less about kind of enhancing your existing GraphQL API, but more about kind of enriching the existing GraphQL app that you have with Hasura. So that's kind of what this piece looks like. And I'm going to pause here, take any questions that you folks might have. This is a first cut release. You can start using it safely from a performance and security point of view, but from a kind of developer experience point of view, from a use cases that you're kind of looking at that you want to make easier, we want as much feedback as you can possibly give us. So please hit us up on GitHub or Discord as you have questions so that we can keep kind of working with you closely. Our community teams, product teams, and customer success teams will be in close touch so that we can kind of take your learnings and incorporate them back into the product and kind of make sure that it's solving for your use cases well too. So I'm going to take a quick pause now and see if we have any questions whatsoever about this piece around data federation and any other questions that you might have too. Just a quick question that I had for folks who were using Hasura with their remote schemas today. Are you folks, are there remote joins kind of use cases with GraphQL that you folks are thinking about that this might be useful for? And if yes, just feel free to DM me on our chat as well, or to reach out. and we'll set you up. Jim has a question on how this differs from using Apollo federated server. That's a good question. I think two main differences. The first difference is that in that Hasura GraphQL gateway mode, if you're looking at Hasura, let me just share my screen again. Cool. So when you look at this, right, and Jim's question is essentially, how does, just a second. Yeah. How does Hasura kind of handle this use case where, there we go. So if you have Hasura here in this kind of GraphQL gateway mode, what if you're using Apollo federated server instead? So that's a good question. I think it kind of works with Apollo and kind of replaces the Apollo federated gateway as well, depending on kind of what you prefer. But at a technical level, the differences are essentially twofold. The first is Hasura does not require these GraphQL services to have anything in addition to being a normal GraphQL server. With something like a Apollo federated gateway, you need these GraphQL services to have federation annotations, right? You need it to have an annotation that says, this is how this type depends on that type, right? Between two services. And that's an enhancement to the GraphQL schema. The Apollo folks call it the Apollo Federation spec. And so the GraphQL services that you're using with the Apollo Federated Gateway need to have federation, need to be federation compliant, right? This is something that's obviously hard to do if you don't own that GraphQL service, or if that's like a GitHub or a Shopify kind of GraphQL service, which is not going to have those annotations, right? So that's kind of one difference, which is that Hasura doesn't need these GraphQL upstream services to have that, to have any extra enhancements on top of the GraphQL schema, right? So just vanilla GraphQL schemas, GraphQL servers will work fine. The second piece, which is kind of a derivation of that first itself, is that the way that relationships are set up is done at the Hasura metadata layer, right? So the burden of setting up the GraphQL services that are going to be a part of the graph is done at the Hasura metadata layer. So that's the collaboration point, right? That's a little bit different from the way that you would work with a federated gateway setup, in which the authors are publishing and registering with the gateway. In this case, it's that they are registering and publishing against the Hasura metadata, right? The same form of publishing, but you're publishing to Hasura metadata instead of publishing your schema to the gateway, right? So your CI/CD kind of remains very similar, but the model is a little bit different, right? So it doesn't require any of these GraphQL services to have those annotations. That the joining is kind of done with the Hasura metadata. So that's how it works. Conceptually, it's fairly similar because almost all forms of being able to kind of join across GraphQL services were conceptually all do the same thing, right? Just like how Hasura has this notion of a GraphQL join where a source field is going into an argument of another resolver. It's pretty much the same concept that you would see in Apollo Federation, same concept that you'd see in schema stitching. And that's because what you can do is pretty straightforward. You can't do much, right? You're basically taking some values from service one and using that to select some values from service two, right? So the conceptual mental model kind of is the same. Like what it does is the same. Just the way that it specifies, where that annotation metadata is differs a little bit. So that's the long and short of kind of how it's different from the Apollo Federated Gateway. Over time, our aim as a provider for GraphQL API is to kind of just play well with the entire GraphQL ecosystem, whether you're using Hasura as something inside a federated system, whether you're using Hasura for a federated gateway, right? Like whatever tool you want to use for whatever features, we just want to make sure that it all kind of continues working well with the GraphQL ecosystem, especially the official GraphQL schema, because that's where the entire industry is kind of collaborating on, but even with the broader ecosystem as well as that evolves. So depending on kind of your use case and your setup, if you have a particular setup, especially that includes Apollo Federation somewhere and Hasura, and you want to figure out how that works together, just reach out to us on GitHub or Discord. We'll be able to help solution that for you and see if that affects our roadmap as well. Nagendra had a question on, so let me just, all right. Nagendra had a question on how does Hasura support federated development? Is it a blog article? In In terms of like a dev workflow, I'm guessing your question is like a federated dev workflow for especially this GraphQL gateway use case. If that's the question, again, that's a good question. I think we should do a blog post or GitHub repo that kind of summarizes that dev workflow well. And so as we set that up, we'll post that out soon too. I think Praveen kind of talks about it in the blog article that we had that announced GraphQL Joins that we just linked to in the chat. But I think a good end-to-end description of what a full workflow might look like would be a useful kind of starter kit, right? So we should set that up. Perfect. Awesome. Dylan had a question on if you have a multi-tenancy where each customer has their own Hasura GraphQL endpoint, we're interested in moving to one Hasura project and GraphQL API with multiple postcards, but each customer has the same tables and views. Is it possible to structure a project with that kind of multi-tenancy? Yep, that's a really, really good question, Dylan. I think there might be two broad options here. You could use Hasura as kind of the GraphQL gateway where you have each person having their own Hasura service. And then you can use kind of different namespaces or prefixes on the Hasura side. But I think on the multi-tenancy example, there are enough controls in Hasura to let you kind of change the type so that it's not conflicting. But I'm guessing, Dylan, what you're really looking for is that all of the databases have exactly the same schema. And what you want to do is based on the authorization token, you want to route to a different quote unquote connection string that is backing the system. Is that correct? Are they exactly the same? Yeah. Okay. Awesome. No. So that's something that we don't support yet. What we do support is that if you kind of namespace them and say, customer one GraphQL schema, customer two GraphQL schema, that works. But that's not what you're looking for. We've had this conversation before with the product team. So if you could raise a GitHub issue that just kind of describes that ideal setup and how it would work, like from a user experience point of view, an authorization token that will just get routed to a different database setup with an example of kind of what a metadata or UI workflow would look like. Just in words, that would be perfect to just get that discussion started and link to other internal discussions that we've had as well. And then we can take that up. It's not, I think it's not, it's not a technically complicated thing. The important thing is just to make sure that we get the metadata experience and the developer experience right, because it can get interesting where you have multiple databases. If they start diverging, you start seeing a problem, right? Like if they start diverging in the different schemas that you have and how we want to handle that experience on the Hasura side, that kind of becomes the challenge, right? So that's kind of something that we've been working through, but that's a very powerful use case. All right. Okay, I think that's all those are all the questions we had. Please feel free to reach out to me on Twitter. I'm at Tanmaigo on Twitter if you have any questions, and then I can answer those for you and route you to other folks in the team as well. But otherwise, of course, the best place to talk and have conversations is on GitHub and on Discord. And so look forward to kind of seeing you folks there. And Krishna Kumar, I just saw a question around how you're using Apollo Federation along with remote schemas and with Hasura. Yeah, that's a really good point. I think one of the items on the roadmap that we're working on is allowing Hasura to be consumed by a Federation gateway as well. So that should ease your setup too. All right, folks. Thanks a lot for joining me this morning, and looking forward to your feedback and hearing your stories.